We know that the rollout of Wi-Fi 6 and beyond enabled access points and routers also then prefer devices that are actually built on Wi-Fi 6 over Wi-Fi 4 based devices. So it's really the transitioning is happening for many reasons, and one very big reason is the enhanced security.
Hey, this is Martha DeGrasse, here again for Wi-Fi Alliance, and this is The Signal, our podcast where we give you the inside track on Wi-Fi. We want to deliver insight and perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. These are meant to be smart conversations with industry leaders. In this episode, we're welcoming Marian Kost back to the podcast. He is VP and GM of Connectivity at Texas Instruments. Marian, thank you so much for being here.
Hey Martha, thank you so much for having me back. We're excited.
Yeah, so am I. Last time you were here, we had a really great conversation about IoT use cases, and today I think we're going to dive into one aspect of that, which is wireless security. And I'm really interested to learn what we can about that. It seems to me that there are so many more connected devices that rely on Wi-Fi and that handle a lot of really sensitive information. Connected healthcare devices come to mind. I was just hearing today about the proliferation of home healthcare devices that can be connected to home Wi-Fi networks. And then, of course, a lot of us are still working from home a lot and having a lot of sensitive information on the Wi-Fi network that way. So I'd like to hear from you, what are some of the new security concerns that your team is focusing on in your development efforts?
Yeah, excellent question. And you're absolutely right. As more and more devices are getting connected via Wi-Fi, more and more end devices, there's also many more devices that carry critical information. And that can be different use cases. You mentioned already in the health case arena, where it's of course about patient monitoring, patient data. There's also other use cases that we are very heavily engaged in, such as in the grid infrastructure space. So think about whether it's solar inverters, whether it's EV charging stations, whether it's metering for metering data transmission. So all that data that is being transmitted over there and received as well is critical for the infrastructure. And there's many, many other use cases. So given that Wi-Fi is proliferating across many more of those devices, there's also the need for higher levels of security. And actually, we are very pleased and heavily engaged with the Wi-Fi Alliance to level up the security demands that are coming with the new standard. And we can see this in the case of Wi-Fi 6 and beyond. Specifically with Wi-Fi 6, the Wi-Fi Alliance has mandated in some frequency bands the use of what we refer to WPA3, which is the Wi-Fi Protected Access 3, which is really an evolution from what it was before with WPA2. Now I can go into lots of details, but maybe I stop here and let me know if we should talk more about the use cases now or more about the technology that we are transitioning into.
Well, yeah, let's finish with the use cases. Are there any that you haven't mentioned that you think are important for people to think about? Because I think that different technologies are maybe appropriate for different use cases, right?
Yeah, that's absolutely correct. But it really spans across. I don't want people to be limited in their thinking of where Wi-Fi can go. It's really technology that goes into heavy industrial applications. We have Wi-Fi in motor controls in factories by now, right? We have Wi-Fi, as I mentioned, across the healthcare devices, whether that's a CPAP machine that you use at home for better sleeping and breathing, or it's a highly complicated patient monitoring system inside a hospital. As I mentioned, the critical infrastructure that we live in, specifically the renewable energy, and a lot of those devices are getting connected today. And it's very important information to balance the grid, to also make sure that the data that is used for the metering, for the billing process is secure. And then, of course, you have all these building automation, home automation use cases. And those are not just in the smart home arena, where it's the personal data of every one of us, but it's also, of course, Wi-Fi inside the more commercial building setups, where it's about energy savings programs, where you control, let's say, your climate control depending on how many people are in the building. And Wi-Fi has a lot of technology across multiple of the end equipments, but then obviously also in the infrastructure itself that connects all those different devices. So very critical communication interface across all of those sectors.
So give us a little bit more information about how next generation Wi-Fi is more secure than previous generations.
Yeah, that's a very good question. So as I mentioned, with the Wi-Fi Alliance and the different revisions of the technology, more security demand has been introduced, which is excellent because that also helps to really make Wi-Fi not just a relevant connectivity method to connect to the cloud, but also it meets the secure aspects that those end devices and the infrastructure actually demands. And so one of the enhancement in Wi-Fi 6 was clearly the introducing the WPA3, which is, especially in the 6 gigahertz band, demanded and highly encouraged also in the 2.4 gigahertz and 5 gigahertz arena. And we see many of those devices using multiple of those different bands. And clearly WPA3 has significant advantages over WPA2, which was the standard before. And that starts with the encryption method itself, where WPA3 is just a much more robust encryption algorithms that is being used. It has also to do with the authentication method that is being implemented. That is clearly a step forward. The good thing is as well that actually the WPA3 also addresses some of the weaknesses that were found in the WPA2, such as a key reinstallation attack vulnerability, which allowed attackers to decrypt some of the network traffic, right? So when you build up a WPA-based system, the router and the client devices must support the WPA3, which really lifts up the security to a new level.
Do you think that most buyers of IoT technology understand that? I'm sure that different industries have different levels of concern about, for example, the type of hacking and decryption that you were just talking about. Obviously, in a smart building, if somebody, there's that famous example from Target, right, where somebody got into their Wi-Fi on their smart building and then got into the rest of their systems. But in other industries, do you think there's still a lot of education that needs to happen, or do you think it's pretty much of something that enterprise buyers are already asking for?
I think on the enterprise side, we see it getting demanded more and more. It is also being, of course, something that is being enforced, I would say, by several standards. When you think about the Cybersecurity Resilient Act, you just need to achieve a higher level of security. And even on the end equipment level, there's new outline policies coming in play in the medical space, in the grid infrastructure space that I mentioned, where people are just have more awareness for what level of security do I need. So let's say the more you have, the better it is at this point in many places, I would say. But I would say there's also still a lot of education needed to translate it into the actual, not just enterprise, but also the personal security. So for example, we are supporting with the WPA3 in our products, both the personal, the consumer-facing security needs, and also the enterprise level of security, which is very important so you can actually operate in an enterprise network, such as you refer to like in the Target case. Those are different levels, again, within the standard and the security, so it's important to translate what does it mean for the end consumer in their own home, for their personal data, and what does it mean for the enterprise system that's already established. What level do I need to have in terms of security to be able to be a viable device inside that established infrastructure?
So are you saying it's a higher level in an enterprise, or it's not that simple?
No, it is a higher level, and it is different. So it's a difference if you have an end device that's within your home and you just add it to your personal network, or if you want to bring a device into let's say a hospital network where there's multiple different security schemes already enabled. So you want to make sure you have even a higher level of authentication and security layer on those devices.
Do you think that in the enterprise that the increased capabilities of Wi-Fi 6 and eventually Wi-Fi 7 are motivating manufacturers of connected devices and IT architects to consider Wi-Fi for use cases that they previously would not have considered Wi-Fi for?
Absolutely, absolutely. And this is Wi-Fi 6 from a security aspect, but also from other aspects in the technology and how the Wi-Fi 6 standard is defined. And I don't want to dilute from the security side of things, but for example, in Wi-Fi 6, you can also have many more endpoints per network. They use the spectrum much more efficient. As I mentioned before, you have different frequency bands, including the 6 gigahertz band enabled from Wi-Fi 6 onwards. Also, we know that the rollout of Wi-Fi 6 and beyond enabled access points and routers also then prefer devices that are actually built on Wi-Fi 6 over Wi-Fi 4 based devices. So it's really the transitioning is happening for many reasons, and one very big reason is the enhanced security, which really gives more trust in the enterprise environment to add devices after the fact to the network, and not only when you initially install the network. That's a very important point. So you have your network there, but the ground rules to operate in that network are stricter. much more robust. And now if you fulfill that, it's much more trustworthy, so to say, to add a new device into that network. And that clearly accelerates the proliferation of Wi-Fi devices into those networks. And also it accelerates clearly the deployment of Wi-Fi 6 and beyond based end devices. And that's what we see right now across the industry.
No, that's good. So that's part of the value that you bring with your chipsets, right, for these devices, is to be sure that they will meet the standards and be ready.
Absolutely. So the one thing is we're meeting the standards. Absolutely. The other thing is that even when you fulfill the standard, there's still additional capabilities and scalability that you can bring to those systems. So for example, we have even optional encrypted interfaces to the processors or MCUs that the Wi-Fi chip might be communicating to in those end devices, right? So now imagine, again, I come back to the example of a medical device or a grid infrastructure device, where typically you have a lot of the end device is sensing your patient data, let's say. Then it's calculating the data. It's taking some pre-conclusions on the edge, sometimes even AI use cases. And now you take that almost ready processed data and you want to get it to the cloud. So then the interface to the main system is also optionally encrypted. So that's what we're enabling as well as we're enabling things like secure boot, secure authentication inside the device. We have devices now that have a full hardware security module on board, which makes sure that every operation inside the device runs through a very, very high level of security before it gets into the networking security, as I call it, where we then comply, as I mentioned, to the Wi-Fi 6 and beyond standards. And that's very, very important. We also collaborate with industry security programs, such as the ARM Platform Security Architecture Program, referred to as PSA, to assess the security of the systems and the devices. We are helping customers and talk with OEMs openly about things like, hey, how does the technology enable higher level of security? Be prepared for new standards or new rules that are being rolled out on a governmental level, such as now the European Union Cyber Security Resilience Act, referred to as CRA, and many other things. So again, it doesn't stop with just being compliant to the networking layer of security, but you need to have device security on the device itself against physical attack as well as software attack in the system itself.
Okay, great. And what's coming up in 2025 as far as Wi-Fi and security?
I think, what we're looking forward to in 2025 and beyond, that continuously the Wi-Fi Alliance will provide certification programs that encourage the transition between generations and also encourage a high level of security to provide the best possible user experience. Because ultimately, all those methods are there, and we talked about it, are really to enable more devices, more straightforward, easier, but not less secure, but more secure connectivity to the cloud. That's essential. And the more the Wi-Fi Alliance can work together, all the parties within the Wi-Fi Alliance work together to make sure those programs are clear, are getting enhanced, also provide the scalability. And when I mean scalability, I also mean affordability, right? So when you look at the Wi-Fi 6 devices, they can range from a 20 megahertz channel device, which is a much more affordable device, to very, very high bandwidth devices for high throughput applications, which are much more expensive. So that scalability, I think, is extremely important. So setting the ground rules for accepted and best-in-class security across the scalability is extremely important, because that will enable, again, to make it much more user-friendly and a good user experience without sacrificing the performance and the security of the end devices. And that will enable a much, much faster proliferation. Especially when you look at there's new Wi-Fi technologies as well coming alongside, where, again, security needs to be a foundation. But then we're talking about new applications like Wi-Fi sensing, Wi-Fi locationing. So much more information that we can get from Wi-Fi enabled devices. And that information needs to be securely transmissioned into the cloud and also received back, of course.
Great. Well, it sounds like there was going to be a lot more work to do in terms of securely transferring data to the cloud. Marian Kost, VP and GM at Texas Instruments, thank you so much for being here today.
Thank you, Martha. Thanks for having me back.
And that is our show. You can get the signal straight to your device through Apple Podcasts, Spotify, Amazon Music, or of course at the Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse here for Wi-Fi Alliance. Thank you so much for listening. Join us next time on The Signal.